Ever written a line of code and just kind of wondered, how does this actually become a working app? Well, I promise you, it's not magic, it's translation. And today, we are pulling back the curtain on the two secret translators that power pretty much every piece of software you use. It really all starts with this one basic question. I mean, we write code in languages that, we can read, but how on earth does the machine, the actual silicon and circuits, understand what we're telling it to do? And this right here really shows you the heart of the problem. On the left, you've got code that makes sense to us, but on the right, that's what the computer's processor actually understands. It's just a long stream of ones and zeros called machine code. I mean, they couldn't be more different, right? And that is the problem in a nutshell. There is this huge communication gap between the languages we like to use and the machine's own native language. So to bridge that gap, we're going to need a translator.
Luckily for us, we don't just have one option. There are two main approaches that programming languages use to get this job done. We've got compilers and we've got interpreters. Let's dig into how they work. So first up is the compiler. You can think of a compiler as this super meticulous, all-or-nothing kind of translator. Its whole job is to take your source code, read through every single line, and convert it all into machine code in one big pass. And this all happens before you even try to run the program. And then, on the other side, you've got the interpreter. And it takes a totally different approach. Instead of translating everything up front, it reads your code one line at a time. And as it reads each line, it just runs it, right then and there. It's a much more direct, step-by-step process.
Okay, so let's imagine our code is about to go on a little journey. First, we're going to send it down the path of the compiler and see what that looks like.
Here's a great way to think about it. The compiler is like a book translator. It takes your entire book of code and translates it from cover to cover, from English to French. And only when that entire translated book is finished do you get to read it. You can't peek over its shoulder and read along. You gotta wait till the whole job is done. So let's trace the actual steps. First, you write your source code. Then, step 2, you run the compiler. It chews on the whole program, checks for errors, and translates it. If everything checks out, it spits out a brand new, separate file, an executable. And only then, as a final, totally separate step, can you actually run that program. The key thing to see here is that translation and execution are two completely separate events. And the big payoff for all this upfront work? Speed. That's the real advantage. The final executable file is already translated into the machine's native language, so it's optimized to run super fast, directly on the hardware. It's a standalone application, ready to go. Okay, hit the rewind button. Let's take that exact same piece of code, but this time we're going to send it down the interpreter's path instead. Now, the metaphor for the interpreter is completely different. This time, imagine a live translator at a big conference. They aren't translating the whole speech beforehand, no way. They listen to one sentence, they translate it on the spot, and then they wait for the next one. It's immediate, it's live, it's a continuous process. The workflow here feels a lot more connected. You write your code, you hand it over to the interpreter, and it just starts going. It reads line 1, translates and runs it. Then it moves to line 2, translates and runs it, and so on, all the way down. See? The translation and the execution are happening together, almost at the same time. So the huge advantage here is that you get instant feedback. You can run code immediately and see what happens, which, as you can imagine, is amazing for rapid development and testing things out. Plus, there's no extra compilation step and no extra executable file to worry about. All right, so we've seen our code take both journeys. Now it's time for the main event. Let's put these two translators side by side and see how they really stack up against each other. Okay, let's break this down. First up, execution speed. The compiler wins this one hands down, no contest. Because all the heavy lifting and translation is done ahead of time, the final program just flies. Now, what about error handling? This is interesting. A compiler will scan your whole program and give you a big list of every single error it found. An interpreter, on the other hand, runs until it hits the first error, and then it just stops right there. And finally, platform dependency. This is a big one. Compiled code is built for a specific system, like Windows or macOS. Interpreted code is way more portable. As long as you have the right interpreter installed, it can run pretty much anywhere. So when you get right down to it, it's all about this one fundamental trade-off. Do you want to put in more work up front to get a program that runs incredibly fast? That's the compiler's world. Or do you value the flexibility, the portability, and the ease of testing that comes with an interpreter, even if it might run a little bit slower? And this isn't just some abstract theoretical debate. This choice of translator has a massive impact on the programming languages we all know and use every single day. Let's look at some real-world examples. So on the compiled side, you've got languages like C++, Go, and Java. These are the heavy hitters used for building things where performance is absolutely critical. Think high-end video games, operating systems, and massive enterprise applications. Then on the interpreted side, you have languages like Python, JavaScript, and Ruby. Their flexibility makes them perfect for web development, for writing quick scripts, and for data science, where you're constantly experimenting and need to see results fast. And that, really, is the biggest takeaway here. The decision to use a compiler or an interpreter isn't just a technical detail. It fundamentally defines a language's personality, its strengths, its weaknesses, and what it's going to be best at. It shapes everything from raw performance to how a developer actually writes and debugs their code. But, the story doesn't really stop there. A lot of modern languages, like Java and even Python, have started using these clever hybrid approaches, trying to get the best of both worlds. It really makes you wonder, as we keep pushing the limits of what computers can do, what will the translator of the future even look like? Definitely something